Greetings, welcome to the first best practices video for first grade. In these videos, we will share what one could expect to see and hear as they visit mathematics classrooms. Take a look at this meme. What makes it funny but yet a little bit sad? This is an example that we've seen with a lot of students. This student was probably only taught one method to subtract and was not exposed to developing an understanding of what subtraction means, not to mention the relation between addition and subtraction. In this first grade unit, that is precisely what students will be exploring, building the conceptual understanding for addition and subtraction. This first grade unit of study will encompass the following key learning goals: solving addition and subtraction word problems, including comparison using objects, pictures, and equations within 10, relating counting to add and subtract within 10, finding the sum of 3 or more whole numbers, and using strategies to solve word problems up to 10 with fluency, such as drawing a picture, making a 10, decomposing a number, counting on, etc. Notice that last bullet. It is not that students must use every different kind of strategy to add or subtract, but we do want students to notice and be exposed to different methods, including comparing when one method may be more efficient than another. These goals can also be found on the STEMscopes parent letter. What should we see happening in the classroom to help students achieve these goals? Here we see snippets from some of the STEMscopes explores. Notice that in all examples, students are not only modeling with counters or other concrete objects, but they are often drawing a representation and then recording using expressions and equations. This is all part of the concrete, representational, and abstract approach, otherwise known as the CRA approach. With CRA, we want to show the connections between each model, so teachers may select different students' models and strategies to discuss comparisons. You'll notice a mini copy of the mathematical thinking and reasoning poster in the corner. This is to remind us that the MTRs are how students demonstrate their understanding of mathematics. These explorations by students in the classroom could demonstrate MTRs 1, 2, 5, and 7. The types of questions we ask of students will help dictate the types of conversations our students are participating in. Here are a few examples of math chat questions from STEMscopes. Notice that these questions are open-ended and elicit thinking and explanations from other students. The conversations elicited by these questions could demonstrate MTRs 1, 4, and 6. As students engage in explorations and discuss their learning, we should hear mathematical vocabulary being used by both the teacher and students. Here is a list of some of the possible vocabulary terms that we would hear in this unit. This list can be found on the STEMscopes parent letter as well. Throughout the unit of study, we should see multiple opportunities for students to demonstrate their knowledge and understanding. This could include students' journals and exit tickets during the explores, show what you know tasks as a follow-up, and students may also use fluency builders with games to practice and elaborate on their content knowledge. These activities also provide the teacher with informal assessments to gauge the student's understanding throughout. These activities could all demonstrate MTRs 1, 2, 3, 4, 5, and 7. As we visit classrooms, we may want to ask students questions to better gauge their understanding of the current content. Here we see a couple of different questions that we could ask to gauge their understanding of addition and subtraction. I could ask a student how they could figure out the sum of 4 and 5. What were you thinking? And perhaps a student might break the 5 into 4 and 1 and use doubles and one more to understand that the sum is 9. I could ask students how they decided which operation to use when solving a word problem. And I would hope that the student can tell me something about the problem and perhaps the actions in the problem, and not just tell me that they saw a keyword. Or I could ask a student, how could you use addition to solve a subtraction problem such as 11 minus 7? I would hope that the student could explain that they could use think addition or counting up to solve, like thinking, 7 plus something equals 11. So depending on the student explanations, these could all demonstrate MTRs 4, 5, and 6. You can see additional problems to ask of students on our mathsmarts.com website as well. Students can continue their learning at home and most likely would want to bring home an engaging task or activity. This activity is taken from the STEMscopes parent letter. Here, students can use everyday objects such as dried beans or cereal. They roll a die and then place that many objects in their 10 frame. This repeats with a parent or other family member. Players take turns until they roll exactly the amount needed to fill their 10 frame. This game provides much needed practice with counting and visualizing values through 10 on a 10 frame. The goal is eventually students need not count to recognize values 1 through 10. Even though this is not in the classroom, this still is a great demonstration of MTRs 3 and 7. Remember that meme at the beginning of the frustrated student? Well, we'll see less students feeling like that and more students feeling like this when they are given the opportunities to develop a deep, meaningful understanding with addition and subtraction. See you for our next best practices video.